Hey, welcome back. We're just going to keep working on section 4.5, and we're currently talking about asymptotes. And in a minute here, we're going to see an oblique asymptote, but not on number 4. Number 4 still actually has a horizontal asymptote, y equals 0. Now, the rule is if the degree in the top is less than the degree in the bottom, then your horizontal asymptote is always going to be y equals 0. The bottom is always going to be bigger than the top, and it's gonna approach 0 as you head out to the infinities. So just looking at this already, that's degree 1, and that's degree 2, and so without further consideration, y equals 0 is a horizontal asymptote for this. So you don't have to think about that any harder. Now, as far as the vertical asymptotes, you're looking for zeros in the denominator. So that is clearly x equals plus or minus 5. You don't have to think real hard here. This is really straightforward. So our choices for our asymptotes are x equals plus or minus 5 and y equals 0. That is part B there. We do have to worry about the numerator in a couple other cases, not so far. We just want to make sure we don't have a 0 divided by 0, and we do not have that situation. When you get a 0 in the denominator, it is 0 and the top is not 0. Anyway, so as far as checking out the graph, all we have to do is make sure we have 2 vertical asymptotes at 5 and plus or minus 5, a horizontal asymptote of 0. Actually, all of these have those asymptotes. So the handy calculator is where we need to run for this one. So get your 3x in there, and when you hit the divide, be sure and put parentheses around that x. X squared minus 25. Make sure your window matches their window, which is a standard window. So we're going to go to Z standard, and it's just going to graph this for us, and we're going to be able to pick this out easily. So without working really hard here at all, we can see that our solution is C. All right, now the next one has an oblique asymptote, and I can tell right away the degree of the top is 1 more than the degree in the bottom. So if you have exactly 1 more degree in the numerator, 1 more than the degree in the denominator, then you have an oblique, what we call an oblique asymptote. Now it takes a little getting used to how to compute that. Long division, it may have been a little while since you've done long division with polynomials. So here we go. Let's go find our oblique asymptote. So here we go. What we're going to do is we're going to take x squared minus 9. We're going to divide it into 5x cubed. It's just like a regular long division. Like if you had 19 dividing into 513, you would ask yourself the question, how many times does 19 go into 51? Well, it goes at least twice, but not 3 times. So I'd put a 2 up here, and then I'd multiply that 2 back, and I would get, well, you get 38, don't you? 38 is 2 times 19. The next thing you do is you'd subtract that from your 51, and we'll have to borrow here. We've got a 4. 11 minus 8 is 3. You get 13, and you bring down the 3. Now, we do the same thing over here. We say, how many times does x squared, although we concentrate on x squared, go into 5x cubed? And the answer is it goes 5x times. Now, this takes a little getting used to. And then you multiply this back through, you get 5x cubed minus 45 x. And just like we subtracted that 38, we subtract all of this from where we're at. You're going to get a 0 for that term that you matched, and then this is going to become positive 45x. Now, this is where it gets a little tricky. You have to see how many times does x squared go into 45x? Well, it doesn't. And so this is our remainder. this would continue on. We would check to see how many times 19 goes in 133, and then we would have our remainder. So let's just finish this out here. So what I'm suggesting is that 5x cubed divided by x squared minus 9 goes in there 5x times plus 45x divided by x squared minus 9. This is the remainder after we divide it. Let me finish that problem over there. If you take 19, how many times does it go into 133? Well, it's a 6 or 7. See, 19 times 7 is exactly 133. So 7, and that's 133. This had a remainder of 0. Now, our remainder, so x squared does not go into 45x, so that lets you know that you need to stop. And so our oblique asymptote in this case is y equals 5x. 5x is our oblique asymptote. Let's see if we can find it over here. We should check our vertical asymptotes. X equals plus or minus 3 is definitely in play. The oblique asymptote takes the place of the horizontal asymptote. So plus or minus 3 and 5x, there's our oblique asymptote. Let's get out our calculator to choose the right picture. It's going to be pretty obvious. 5x is a positive one, so neither of those are the correct oblique asymptote. So it's either that one or this one. So we just have to get it just right. Now, the difference between these two is actually a little bit subtle. It's actually the steepness of this curve here. And so the calculator is the only good way to find this out. So you got your 5x cubed divided by, you got your x squared minus 9. We're going to do, you could start with a z-standard, but that's not the graph, that's not the window that they chose here. Our oblique asymptote is actually pretty steep with respect to that one. Now, if you take your window, we're going to widen the y range to go out to from negative 100 to 100. Graph. Now, this steepness right here, this is, let me copy this over so I can draw on it. That line, y equals 5x, in fact, if you put 5x in there, you'll see that is that steepness right there. And so just looking at the two, man, that is really tricky. Which one is right? I'm feeling it. I'm thinking this one, C looks a little too steep. It's a little less steep. This is a little too steep compared to that y range of 100. And is there anything else that would strongly indicate a difference here? I mean, everything else is almost identical. The only thing I see that's different between these two graphs is that steepness. And maybe you could kind of use, where does this hit compared to where does this one hit? This one hits a little bit. See, this hits right in the middle there, around 50, and this one hits a little bit higher. Man, it is subtle, but I would say D is the correct solution. That's about it for now. That was a tough one. I'll come back and do a few more.